Oh, hey there. Alexa, stop. Alright, hey guys, so I'm ready to start this presentation. I've been waiting for a while for this, so let's get started. First of all, my name is Stuart Brunt, and I greatly appreciate your time. This is going to take a little over 25 minutes. The purpose of this presentation is to explain why I'm excited about completing this program. I also want to introduce a positive outlook on the effects of globalization and automation, and inspire fascination about these new frontiers of discovery that technology is revealing. And also, I want to explain, illustrate why I believe that this program is the foundation for a morphing career. Globalization and automation. These two phenomena are inextricably linked. They feed into each other. These propitious mechanisms lead to new frontiers of discovery and human potential. These agents of change are paving the way for the evolution of jobs and the introduction of new ones. Thanks to globalization and automation, it is an intriguing time to begin a career as an electrical instrumentation technician, a job that will continually transition from what it is now into diverse sectors of manufacturing needs, a job that hinges on the need for industrial facilities to require more control and monetization of the products and services they generate. Globalization means complying to global standards of various types: economical, political, cultural, educational, environmental, and other types. It describes the way that countries and people of the world interact and integrate. Many things have become globalized as more people come into contact with each other. Globalization allows us to come together and become a more integrated society. It allows us to find new solutions to existing problems, create new problems, and then create new solutions to these. It spurs us to make new connections and pathways. Globalization lets new processes form and merge with other processes. This means great things for society. It is my belief that the world is full of very important problems that desperately need to be addressed. People don't have the means or understanding to reach these solutions. With the help of globalization and automation, we can make the world a better place. Yes, there are drawbacks to these mechanisms, but I won't go into detail about them in this presentation because I want to focus on the optimistic side of change, and also I believe that these drawbacks will work themselves out over time. Now, what about automation? What is it, and what is its relationship to globalization? Also, how does all this trace to electrical instrumentation? Automation is the creation and application of technology to monitor and control the production and delivery of products and services. Automation thrives on finding new technology. In doing so, it boosts efficiency and effectiveness. We all benefit from improving technology. Plants like this are full of automation. Globalization has led to most of the technology in this plant and will allow for newer and better technology to be integrated into plants like this. Industrial facilities like these are getting better at monitoring and controlling operations within them. The better we get at monitoring and controlling our plants, the more we are cognifying them. This leads to higher degrees of efficiency, which leads to more money. It also leads to more effective methods of creating higher quality products. What's not to like about that? This is a testing before automation tools were made. Automation tools help us to better understand what's happening in the process. And that's where we come in. We do work. We get it done. We work in the field and in labs. We are the work ants. Automated systems working correctly. We test, certify, install, inspect, repair, maintain, and assist in the development of complex instruments that measure and report changes in industrial environments. Understand that industrial facilities are constantly regulating processes, and we are equipped with the fundamental knowledge of how to ensure each process can be controlled very accurately. We use different sensing elements, measuring elements, transmitter elements, control, and final elements to keep the process at desired set points. We have a fundamental knowledge about all types of process applications. We understand how to read control, instrumentation, and piping diagrams. We know about computer ladder logic. All of this right here is our foundation of knowledge that we're going to use in the field. And it just keeps going. We have knowledge in, how power and voltage and current and resistance all have relationships to each other. The laws of thermodynamics, gas laws, different ways to measure level in a tank, digital circuitry. We know about, AC and DC current. We know about inductance and transients and spikes, series parallel circuits, trigonometry, resonance. These are some of the terms that we studied in our program. Capillary tubes, band, bias, accuracy, precision, sensitivity, undershoot, overshoot, deadband. These are some of the things that help give us this foundation. We're big on teamwork. We have calibrated various things, and we understand the importance of preventative maintenance. We're familiar with different popular name brands in the industry like Honeywell and Allen Bradley, Rosemont, Yokogawa, Fluke. And very importantly, we understand that safety is the most important thing. We know that tools do not make mistakes, people make mistakes. We are very aware of the importance of keeping a high level of vigilance and awareness in the work environment. Safety is our number one goal, followed by quality and production. So that's our foundation. But how about, why is it morphing? Industry is transitioning to new methods of design and production. Some things like 3D printing are going to revolutionize work in many domains. 3D printing will allow us to make tools and complex pieces even cheaply. It can print many materials, including metal. It can integrate different materials, thus giving a component a new structural integrity that is unique from the individual materials that make the printed part. Things like 3D printing are causing the automation to change in excellent and exciting new ways. Augmented reality is a technology that superimposes a computer-generated image on the user's view of the real world, thus providing a composite. We already know about things like Yelp and Pokemon Go, but how about how it's going to affect construction or the medical field and education? Augmented reality will change the way we work. Very cool. Virtual reality is another technology that will change the way society operates. It will serve many fields of work, and perhaps electrical instrumentation technicians will find themselves having to acquire skills in programs that harness VR to serve industry in fitting ways. The field of AI research. This defines itself as the study of intelligent agents. This is any device that perceives its environment and takes action that maximizes its chance of success. So what it does is it uses, first of all, it's in all types of applications. It's being used. It's on our phones like Siri, our computers, Cortana, Google, Amazon Echo, and what it does is it uses algorithms that basically perceive its environment, and then it takes action to towards, maximizing its success of some goal over and over and over again. And it can make sense of all this data and quickly see the things that it doesn't need to see and the things that it does need to see. And it can do this of an array of information and make sense of all types of things very, very quickly. And it does it much more efficiently than people who are, inherently prone to making mistakes, especially when things get more and more complex. And when it comes to AIs and technology, things like quantum computing are going to make a vast difference as well. Quantum computing is here. Okay? It uses things like qubits instead of bits. These are quantum bits. Alright? There's a classical bit, and there's a quantum bit. And it's kind of complex, but it's basically a 0 and a 1 at the same time. And this quantum computer, okay, it works in an environment that's the coldest environment in the universe created by man. It's so close to absolute zero. And it's going to change the way that computer systems can perform and do optimization calculations. Very, 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 very interesting. And very, very, very real. This is here. And as proof of that, this is a company called D-Wave. And they are using quantum computers now and working with other companies to accelerate quantum computing in many industries. Use of them. So, with that being said, there's also generative design, and this is extremely awesome. Generative design is a form-finding process that can mimic nature's evolutionary approach to design. It can start with design goals and then explore innumerable possible permutations of a solution to find the best option. By using cloud computing, generative design can cycle through thousands or even millions of design choices, test configurations, and learn from each iteration what works and what doesn't. The process can enable designers to generate brand new options beyond what a human alone could create to arrive at the most effective design. So like this image right here, okay, this car chassis, for example. This car chassis was given a few parameters. It needed space per motor that weighed a certain amount and that were a certain size, and it needed to go a certain speed. These parameters were put in, and the generative design software created and tested thousands upon thousands of designs and optimized for this result. So this type of thing is going to just come into play. When you take this technology and you couple it with 3D printing and other things, AI, it's just going to be unbelievable the way it's going to impact jobs in society in many, many ways. And technology, it's coming together thanks to globalization and automation. We're finding so many solutions to challenges at a rate that's exponential. And speaking of exponential, if you look here at the growth of population, almost 2,000 years, 1800 we had, a billion people, and since then in 200 years, it's gone up to over 7 billion. And this graph right here just kind of shows it, so where you can really see just how much we're really exploding in population. And this is a density chart of this from 2015. Now I really want to focus over here on this eastern coast of China and Japan, because that's going to come into play later. So as the world continues to increase in population, there's more people coming into contact and thus interacting and integrating with one another. This increases globalization and automation even more. So how does this impact my career? Well, when I click on these links, This website here is explaining all about how Charleston is going to be the deepest port in the eastern coast of South Carolina, and how that allows us to take in boats that are now 1.5 times bigger. Imagine how that's going to impact, import and export in the case of a year, 2, 15 years. It's going to be great. So, about, this website. Well, this explains right here the history of railroads in South Carolina. All about how in the 1830s, we competed with Augusta because people in the Piedmont region were going to try to get to the Savannah Harbor, and we ended up making a road to, a railroad to Hamburg, and then to Columbia and Camden, and it just spread from there. So that railroad infrastructure that's wonderful. And you also got this website here that basically is, it is, let's see here. It says it's the largest and most comprehensive directory of South Carolina information on the internet. And what I'm getting at is when you come here, you have, all these jobs. You got South Carolina aircraft and parts manufacturers, South Carolina aluminum manufacturers, ceramic, South Carolina chemical manufacturers, West Rock, DVD. We got all these manufacturing plants here already, and we have more coming. So South Carolina has a lot of jobs for us, electrical instrumentation technicians. Jobs that are here that are going to grow. Jobs that are going to continually transition into newer forms. So it's looking pretty good for South Carolina. It's looking pretty good for our career in electrical instrumentation. So earlier when I was talking about the eastern coast of China and Japan, how they're densely populated, and we really want these areas to shift with us over here in South Carolina. And so far, they have, instead of going this way, through the Pacific, they've been going through, the Suez Canal. But that's changing. Now they just go straight across the Pacific, and they can come through, the Panama Canal that's been widened. And they come to good old South Carolina, where we have our awesome Charleston Harbor. Thanks, Charleston. So, now, electrical instrumentation. In this program, I just finished a co-op last semester working with Showa Carbon. They make, graphite electrodes that are used in electric arc furnaces to melt and recycle a lot of the world's steel. This is my rinky-dink lab that I work in. And these are some of the parts of the plant that I took pictures of. Not the best pictures in the world, but pictures none the least. These are some of the pictures from our class where we had flow simulators, PLC simulators, positioners, and we worked on various instrumentation. And throughout the course of that co-op, I wrote a journal. These are some of the things that were in my journal. I listed some of the classes that I've taken up at that point, the teachers that I've had. These are some of the things that I've done. I used Flute 743D, transmitters, replaced faulty RTD, various things. It was a good experience. I kind of want to point this out. The lens through which I see the process has been largely shaped by the teachers and courses that I have been involved with at OC Tech. From intriguing 8 a.m. physics classes with Donald Walther to compelling engineering ethics topics with Stephanie Phillips and tedious attention to detail smelted by Miss Sharice Jackson. On and on through each teacher and class that I have taken in the instrumentation program. Each class has had an unparalleled impact on my life in positive, useful, and applicable ways. These are tools that I've used and different devices that I've been around. Brilliant process meter, Fluke 771, Fluke 753, EcoLink Electron is a solvent. What I'm getting at is all this has given me a foundation for a career that is changing and transitioning into new things, and it's exciting because I remember when I got my first cell phone. It was a flip phone. I thought it was amazing. Now I have a phone that I can't live without and provides astronomically more capabilities than the computer my dad used to make a living growing up pales in comparison to the one that I have now. And this Tesla, it outmatches old modes of four-wheel transportation light years. I'm all about some Tesla. And the tools that technicians use today, are more advanced than the ones used years ago. Industry is morphing. So too is the career for instrumentation technicians. So with the foundation of electrical instrumentation, I'm equipped to aid in the advancement of globalization and automation. I accept that this career has an inherent evolution associated with it. I am excited about the new possibilities that are in the near future. I am not 100% sure what to expect, but I know that when I look back to the day I graduated this program, I will remember that my foundation paved the way for a morphing career.
Growth matters a lot. If we look at the history of growth, times of big growth have always been fueled by big manufacturing revolutions. It happened 3 times every 50 to 60 years. The steam engine in the middle of the 19th century, the mass production model in the beginning of the 20th century, thanks Mr. Ford, and the first automation wave in the 1970s. Why did these manufacturing revolutions create a huge growth in our economies? Because they have injected huge productivity improvement. It's rather simple. In order to grow, you need to be producing more, putting more into our economy. This means either more labor, or more capital, or more productivity. Each time, productivity has been the growth lever. I'm here today to tell you that we are on the verge of another huge change. And that this change, surprisingly enough, is going to come from manufacturing. Again. It will get us out of our growth slump, and it will change radically the way globalization has been shaped over the last decades. I'm here to tell you about the amazing fourth manufacturing revolution that is currently underway. In the next 5 years, the next billion consumers in China will inject more growth in our economies than the top 5 European markets together. This fourth manufacturing revolution is a chance for all of us. If we play it right, we'll see sustainable growth in all of our economies. This means more wealth distributed to all of us and better future for our children. Thank you.
Key to creating the next generation of smart factories is the development of easily scalable network machines that can provide information about every step of the manufacturing process.
Automated factories generate data at every step in the manufacturing process.
By interconnecting every machine in a factory, a complete view of the materials and processes can be visible to everyone on the team.
New generation of large bots are being targeted to provide better speed and user-friendly interfaces.
At the same time, vision guidance systems help larger robots more accurately pick and place smaller objects with greater accuracy.
Because of these developments, in the near future, product design teams will be able to access real-time information from a series of connected machines and robots in factories worlds away.
These highly automated connected factories will give tomorrow's designers a greater grasp of their product design cycle and the data to track manufacturing and delivery.
And who knows, maybe one day we'll have factories so automated we can turn the lights off and just go home.